Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate. I'm your host, Nathan Oakley, and if you're new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. If you would like to support this channel, there is a super chat that runs alongside each of these shows while they're live, and there's also a PayPal link in the info box below the video once it's rendered. But most importantly, if you would like to join the discussion, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the shape of the Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using stock accounts. You'll be warmly welcomed back on the next stream. Please also share the show. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel. So please share the show. And one last time, if you're new to the channel or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now we are joined by The Plain Truth, Sleeping Warrior, Ranty, Mark Doxy, and Arwin. How are you all doing?
We're all well.
Good afternoon.
Good afternoon.
Hey Nathan, why is the title of the hangout called Flat Earth Math Debate?
Flat Earth Math
Charles
Debate? Well,
Yeah.
that all will become clear shortly, Arwin.
Once we get enough bums on seats and we get about 100 people in or so, then we'll just launch into a bit of an attack.
Oh, we've got an agenda.
Are you expecting Charles to join the hangout?
No, he's teaching summer school, so he's not able to make it, but we do have a concise version of events for us to consider, laugh at, and laugh at him. So when we get further into the show, it's glorious.
You did a hangout with him. Was it last night? Was it or the night before?
Yeah, a couple of days ago. It comes from I shared a link that was in for my input on his show. I asked him would he let me mirror, and he did.
Yeah, I watched it. Yeah.
And I mirrored it, and basically, Charles knows that there is no curve because he starts giggling, smiling while he's talking, and you can tell when someone smiles when they talk because you can just tell. I don't know how you can tell; you can just tell, and the guy knows that there's no curve. It's great. So we'll come back to him in a bit.
Yeah, all this time we've been arguing about what's happening at the horizon when those wind turbines are giving us an elevated, dead straight line.
The wind turbines prove that there is no curvature to the Earth.
And all this time we were looking at the bottom of them when the top of them. Look at the top of them. It's brilliant.
We could do that. I tell you what. Should we do the turbines one now then?
Let me jump in real quick.
No idea what.
Hang on. Let Travis say.
I was able to finally listen to yesterday's show in its entirety, and I found it really interesting when Nathan was grilling Dean.
You mean
where?
Yeah,
I'm sorry.
Cat Earth.
You mean Cat Earth?
Oh,
It's
yeah,
not
whatever.
Cat Earth.
Yeah, sure. And this. Okay, so Dean was saying, I find this very interesting, and I need an explanation. And Nathan was like, "What do you need to explain? We see it. We just see it." And he says, "What I need to explain it. I need to have." And that is the essence of scientism. That is the essence of it. They then venture into a mind construct of explaining something without scientific evidence or proof, which is the same thing that Copernicus did. Copernicus is looking up into the heavens. He sees retrograde motions, and he simply imagines what the explanation is, and then you simply symbolize that with math. So we had a case in point yesterday with Dean demonstrating to us the precise mindset of every scientist when you see a phenomenon in the flat plane world that doesn't fit your mathematical model. You then have to create a construct to explain it. And it was just a picture perfect cognitive dissonance demonstration yesterday, in my opinion. I thought it was brilliant.
Yeah, well, they have to adapt the model, basically. And they can't because, the looming effect that is required to bend the entire globe into a visual flat plane can't be done. they can't do it. It's too difficult. So
There was an element of honesty with Dean yesterday.
yeah, I spoke to him for over an hour afterwards on Skype.
And he's not Cat.
No, he's definitely not Cat. He watched his channel and he says that guy has a completely different accent. So, and
What
I
are you
kind of
talking
believe him.
about?
Cat is a very unbearable individual, and this guy is a really polite.
So you're
Smart
asserting that
guy.
that's not him, right? So you must have evidence that it's not, right?
Well, from everything I heard on the debates about Cat Earth when he joined, this is definitely not him.
I don't agree with you at all.
Pete Shake seems to think he knows who it is.
It would be like someone. It would be like Alan coming on and not giving us "Hello, boys." However he talks, it sounds like a fake, a fake,
Yeah, of course.
a fake voice. So if he would come on and talk in his normal voice, and you would hear some echoes of Alan, but not sure, and then Anthony would say, "Hey, wait a minute, you're Alan," and he'd say, "No, I'm not. What are you talking about?" That's what we're in. This whole situation with Cat, but neither here nor there. I was impressed with Dean's demeanor in terms of the way he presented himself.
Dean showed himself on camera the full way.
Yeah, but
in our Skype call.
Has Cat Earth showed himself on camera?
I don't know if he has. You said he did.
No,
I said
Alan
that-
said he did. Alan said he saw him.
Yeah. Oh, now that means anything.
Yeah.
It's one of those like Superman's got no glasses and Clark Kent's got glasses, so it can't be the same person.
That's a false analogy.
So if you didn't see the show from yesterday, the clip that Plain Truth's talking about, I've literally just rehashed it and re-uploaded it on mine. It's not the whole part of it; it's been reduced down. But basically, he's a curve denier. He thinks that we live on a curve, but when we see it real world, he can't see the curve, but he thinks it's there anyway. So he denies that there's no curve there. So he's really a no curve denier. But it's
Talking
anyway, it's on
about
my
Dean
channel
again?
anyway.
You talking about Dean again?
Yeah, and Ruhif does the same.
Yeah.
Ruhif.
Well, I would make a clear distinguishment between the two. Because Ruhif is really just a stubborn glober, and he rolled over to the dark side of them. This guy is not the same. He is genuinely on the fence. As I said, I talked to him over an hour afterwards, and he is very much open for considering alternatives. But yeah, he has a lot to consider, and he also said that yesterday.
I liked him. I liked Alex. I liked whatever his name was yesterday. I thought they were both decent people.
Dean.
Fools, but decent people.
Yeah. So he just needs some time and some more conversations with me.
Some more conversations with you would probably put him off.
No,
That wasn't fair.
True, though.
no, just for you.
So, are we going to do housekeeping?
Any signs of curvature, anybody?
Nope.
Axial rotation? Anybody
No, hang
understands
on,
that?
the curvature one. Slice Arcane claims that he had curvature in mind, but when put to the test on my own evidence, he ran. So I think we'll have to drop him now. He didn't have any evidence of curvature in my evidence after all. So no, the answer to that, we can't call Sly anymore because he doesn't have any evidence of curvature in my thing. So
Pressurized system next to a vacuum?
Red's rhetoric claims he can explain that one away with gravity.
Right, Red Rhetoric, if you're around.
Explaining something doesn't mean you have proof for it.
Sure.
It seems that we've forgotten about one of the main points that we've had recently. I don't know
Model
whether
9
we've been
core.
sidetracked intentionally or whether it's been accidental on our part, but we kind of need to go back to something that's been almost forgotten about.
Oh, we'll get back to the turbines. No doubt about that.
No, I was on about the perspective argument about how things get smaller as they get into the distance, and then you apply the curve to it.
Right.
Perspective.
Yeah, I mean, I think this was all wrapped up in one big sandwich.
Yeah, I do too. The answer is always at the horizon, but that's where they tell us the curve is. But actually, it's not curve that's at the horizon. That's the obstruction formerly known as curve.
Right, dirty air, point of convergence. etc., etc. So yeah, I mean, we're on that perspective wagon as we speak, and yeah, we could drum that point home again. I'm happy to do so, but I just think the turbines are an excellent example. Mark mentioned them earlier, and he's right. He's absolutely right. One of the first things you told me when we first started chatting, Anthony, was that Dazza the cameraman had took you to one side and explained that we use the refracted hidden value. In other words, they're demanding that you look at an area that is refracted and then accept it as the hidden value based on Earth curve obstruction. Well, no one could ever argue that, because there is a refracted band at the point of convergence if it's not obscured by waves that are crossing the midpoint, if it's a particularly rough day, or not even a particularly rough day, if you're just low enough for that to happen. So if you can see it and it's obscuring stuff, they can class it as Earth curve, and if you argue that we can just see it because it's there, that band is a refractive band. So they seemingly have all bases covered, until you come to something like these wind turbines, where they're out of the refractive band and they're still falling away with in line with perspective, all these same height items. They're a very useful tool to measure whether or not we have any curve. And when these guys are drawing lines on these turbines, the best they can achieve, if it was actually curved, is a line of best fit. That's what they're hoping for, because that would indicate some sort of curvature. Definitely not a linear line. That demonstrates that the Earth is absolutely, unequivocally flat.
Yeah. So there's 125 watching now. So I think what I'll do is I'll click on my Charles Knows video. Nate, do you want to present me? Let me know when we're there.
You're on.
This is quite cool, although there sounds like there's some kind of truck
you've
going past
stopped.
me in the
You've stopped
background.
screen sharing.
I'm not screen sharing.
You've just stopped.
Oh, did I? Did I hit the... Oh, sorry. Let's try it again. That better? Nope.
No, just got your swinging warrior.
Right, hang on, let's try it again.
Did you say swinging warrior?
I did. You'd have just shut up. That would have been a good joke. Sort of.
Sometimes it's the silence that makes the joke funny.
Exactly. Yeah, you're screen sharing now. You're up.
Right, okay.
Got the hangout. There we go.
This video is a consolidated version of the hangout that I had with Charles on Charles's channel. And basically, in the video, he giggles or smirks whilst he's speaking, and I pick up on it straight away, and I basically challenge him there and then. And it is the point of this video. Charles knows it's not a ball because he smirks while he... Basically, I say that you can't have sphere lines that are straight. They've got to be curved, right? And what I did was I asked him, could I share the video? And he said, yeah, you could. But then when he's seen the video, he's basically not happy with it because he says, the Earth is not a spinning ball. That is a fact. I stand behind everything I said here. And I still don't think that you got that the accumulated curvature causes the rear group of turbines to be at a steeper angle. Are you an accumulated curvature denier, Anthony? So what I want to do, I want to focus on this line in a sec. I still don't get it. It's there we go. The accumulated curvature causes the rear group of turbines to be at a steeper angle. So what we'll do is we'll check to see is that true. And what he's actually doing here is basically reciting our argument against us to make it look like he's credible. But this is our argument. This is what should happen if there is a sphere, because the rear group of turbines should be at a steeper angle because they're double the distance away. It might not be a lot, but it should be noticeable because it's getting worse the further around the ball it gets, and it is 20 miles away. We can see curve at 20 miles. Anyway.
But just got to add one point. I did ask you to do this before we started the show, but the point being there shouldn't be an angle. There shouldn't be a straight line. So while he's comparing angles of stuff, lines, he shouldn't be. There shouldn't be any straight lines at all.
Sure, but let's come back to that in a sec, because I just want to show the message that he's put here, because we'll go through it as a group and laugh, because it is hilarious. I said, Charles, try and come on the show today. I want this comment addressed. It'll be addressed at the start of the show. Hopefully you're there to defend the evidence that you know does not support your position. And then he said, thanks for the invite, but I'm teaching summer school. I wonder what you're teaching them all at summer school. Anyway, he won't be able to make it, but he'll reiterate his points. The reduction in size due to perspective from the first turbine to the last is tiny. Well, no, we see it in the picture. This is perspective that we're looking at. So whatever the reduction is, this is it. You're looking at it because there's no evidence of curve here. This is perspective, but it's not tiny. You can plug the numbers into any angular size calculator, yet the actual height of the turbines is at a far steeper angle. Really? Well, we'll check that in a minute. This steep angle is what you were referring to as the accumulated curvature. Well, okay, so this is one of the. There's loads of pictures that Rancy's got. So basically, you can just pick a picture out of any of the videos, and they're all the same.
Let's say a quick hello to Zach. Hi, Zach.
How's it going, gentlemen?
Very well.
Hey.
Good to have you. Carry on, Anthony.
So the first point is, like, as Nathan correctly states, that that you can't even have a straight line, right? You can't have a straight line at 20 miles away on a sphere. It does have to start to curve. But as you can see, like as I overlap the lines there between the turbines are on the same angle, regardless of the fact that it's straight or not. It can't be straight. So I'm emphasizing that for the benefit. It has to be curved, but it's also parallel, right? These ones are only 10 miles away, but these ones are 20 miles away. But it can't be the case if we live on a sphere. So what should be the case with these ones that are 20 miles away is it should be more like that as it gets further around the ball, but it's not. It's parallel. So Flat Earth Math's position is the reduction in size due to perspective from the first turbine is tiny, yet the actual heights of the turbines is at a far steeper angle. Well, it isn't the parallel, and that cannot happen on a sphere. The steep angle is what you were referring to as accumulated curvature. That's nonsense. That's not right at all. So then he would say, Flat Earth Math would argue that the back turbine does appear to be shorter than the front, about the size of a house. Well, that's because of perspective, right? There's no evidence of curve in the picture. The housing part of the turbine behind the hub holding the machinery is the size of a house, and the curvature drop is even more than that. You can Google search Vatten turbine Ormond. Well, let's just say that these things are as tall as a house. You would need to see that being the curve over all of the turbines. So the difference between the two lines, as Flat Earth Maths has just pointed out, if I bring this down a bit, is that if he's going to argue that the depth in the turbines is the height of a house, well, that's the difference in the line that it should be curving. So it should be curving by that amount, and it's flat. It's a straight line.
Hey, Jose.
There is no evidence of curve, right?
No, it's flat. It's a straight line. It's a linear relationship between these turbines, and you cannot have that. Number one, you need them to curve. And as demonstrated in models, even when you've had the best case scenario and you're only looking at the isolated set of turbines from a very close proximity, you still only get a line of best fit if it's curving, if it's built on a sphere. They don't have that. What we have in reality is a linear line. Hi, Alan.
Hi boys.
Wow.
Quite warm today.
Hey. So I just want to focus in on this bit here. He reasserts his position. He doubles down. He says, I would further argue that the front group of turbines is at one slope angle and the rear group is at a steeper angle due to accumulated curvature drop. Well,
before we all get sniped, Ruhif, can you speak up?
Yeah, it's me. Hey.
All right.
Hello.
So the angle here is exactly the same. There is no curvature angle reduction or change between the two sets, and that cannot happen on a sphere. So when he's further arguing that, the evidence doesn't support you. Unfortunately, I agree with you. There should be a change in the slope between the two distances at 10 and 20 miles, but there is not. It's parallel. How? Because there's no sphere. It can only happen on a ball to do what you say. But
further to that, though, it's not a slope. It's got to be a curve. Just got to get that in.
So it does have to be the case that the line in the background has to be more severe, more acute, or more steep, right? But it's not.
Not more. No. Not more steep. Curved, more curved.
And on a different angle.
Yeah, more curved.
Different angle, yes. Not more curved.
Yeah, the best you can achieve if it's built on a curve is a line of best fit.
So I agree with Flat Earth Math. If these ones that are double the distance away, it should be like that. To some degree, like you mean, you can argue about the angle of it, but there should be a difference in the angle, and there's not. It's parallel. So how is that possible? Look again at the bases of the front group. This is excellent, right? Look at the bases of the front group. The very first turbine columns show the black at the bottom of the orange, which is gone by the last ones. The orange itself is actually shorter, much shorter than due to perspective reduction in size. You can run the numbers yourself. Well, okay, let's consider that. What I'll do, he's talking about these near ones.
Hold on,
So
sorry, sorry to keep interrupting. So he's saying we can run the numbers on the perspective difference. Why? They're not applied in the mathematics.
Yeah. Why would we want to run the numbers on perspective then, Charles?
Yeah. It's
Because
not
you've
applied.
not done.
It's not applied, but Charles Flat Earth Math seems to think it's applicable. That's why he's telling us to, quote, run the numbers on perspective. What have you got to say about that? Do you want to tell Charles, Ruhif, that you don't need to run the numbers?
Well, hang on. Because this is a really strong point. We'll come to Ruhif in a sec.
Okay.
So we can see that we've got the line going straight through the hubs there, and there's no curve on display. But what he's saying is if you move the line down, I'm going to line it up with the first one, because if it's curve of the Earth that we're seeing, we should see it follow the same pattern. If this is curved that's supposed to be straight, then you would expect it to be the same underneath, because these are all the same size. But as you can see, look at how the line doesn't even get anywhere close to it. It pulls away, it goes up. So what appears to be happening is the further the turbines go away from the first one, they seem to be squashing up from the bottom, and they're coming as well as, well, basically the tops of where they are, but they seem to be being pushed upwards and squashed, because otherwise that's where they should be. They should be on a straight line consistent with that. But for some reason, they're not. Why might that be? If it's supposed to be a curve and we're seeing straight line as curve, then it has to be the same at the bottom. But we're not seeing that. So how is that?
Can I ask a...
Just before you do, Ranty, can you cue up your magical boat picture, please, with the turbines behind and one exposed, please?
Can I ask a question first?
Yeah.
Go ahead.
Sorry.
All right. So we see the line of water, right?
Yeah.
Okay, and the turbines behind it. So the question is, how far away from that line of water are the turbines? My question is there any way to determine from the slope of the angle, the red line that you've got, is there any way to determine from that what the distance might be from angular trigonometry?
I don't know.
Do you understand my question, though?
Yeah, you're asking, can we use the line to determine how far away from the horizon they are, right?
Right, because the horizon line that we're watching with the water is flat. So by extension, the turbines are flat. So then the question becomes, what's the distance between what we can see at the water line and where the bottoms of the turbines would physically be?
I have no idea. I don't know. You'd have to.
Sorry to interrupt. If I can draw your attention, if you can click on Ranty's pictures, he's hopefully going to go back a couple of shots and get this boat in front of these turbines. It's not quite the right boat. Do you know which one I mean, Ranty?
I'm trying to think which one you want. This one?
No, it's just where the boat is directly in front of almost all but one of the turbines. I'll just let you flick through while you're finding that. If you don't have it, I took a screen grab of it, which I can send to you if you haven't got it to hand.
That's all there is on those images, so it can't be from them.
I wonder if my question could be addressed somehow with the two sets of turbines, because if you know the distance between the two sets, and you can measure the angle of those somehow.
Oh, where's it gone, Ranty? Oh,
was that it?
I wanted to see it. There's one that you've got where you've got the boat going in front of the turbines.
Sorry.
You've definitely got it somewhere.
I think this was the 10th of July, this one. I can always check through the other ones if you want.
Yeah,
but this is all there is.
Yeah, if you can dig through I may have took a still from a video, but I could have swore it was a still.
It could be from the video, to be fair. It's where the boat's
Can I throw
going,
2 cents in on that question that he asked?
Go ahead.
That line of water will change. It will get higher, it will get shorter, depending on the atmosphere. The atmosphere affects the rate of your angular resolution limit of your eye. It changes how much is being blocked along your horizon.
Does the same
so that's
No, correct. That's correct, but the distance to the ground also matters a lot.
Yes, yes, absolutely. That would change the angle of elevation to the object. Yeah, absolutely.
Zach, does the same
Yeah.
thing apply to a camera lens? You said to an eye.
Absolutely. Anything with a circular aperture, Airy's diffraction will take place in the center along the horizon. That's what creates that horizon band. I'm going to be doing I got to get going back into work, guys. I'm sorry. I just saw the Hangout link and I decided to jump on for a sec.
That's correct.
But tomorrow night on Iron Realm, we're actually going to be covering all this, and we were going to ask you guys to come in. You, Ranty, Nathan,
Sure.
you know, all three of you guys.
Free,
We'll get a hold of you and all that good stuff.
Cool.
But yeah, well, I was going to go through how the eye picks it up, how Airy's diffraction affects a single point source of light, and then when you start adding the point sources together, how that all works. Yeah, we're going to break it all down.
Cool. So, covering the circle of confusion, basically.
Yeah, yeah.
Cool. Excellent.
Yeah.
Oh, I'd love to get involved.
So,
Absolutely. I hope
yeah,
I'm free
absolutely. We're
tomorrow
going to
night.
be getting a hold of you guys here probably this afternoon sometime.
Cool. That's ace. Absolutely awesome. But yeah, you're spot on. We'll let you get on. Thank you very much, Zach.
Yep. You guys have a good one. I'll see you guys later.
Thank you very much. But yeah, Zach's absolutely right. As you look down the length of one of those turbines, the angle that you're looking at it decreases. It's narrower.
Just a placeholder.
Hey, James. Hey, Jimbo.
He just said he's here to placehold.
Cool.
Yeah, I can't find the one you're talking about, Nathan.
God damn. You're joking. Just when we need it to make that point. I'm sure it can wait. I mean, I'll dig it out from you off air.
You got to label them, Ranty. Label them.
There's that many.
But if you can keep looking, because you definitely had it, and I thought I'd screen grabbed it, but I haven't. Maybe I've screen grabbed it on my phone. I will have a look. But as someone's just plugged Iron Realm, I'll plug my show later on this evening, so 8 p.m. UK time. Johnston, you will do Flat Earth proofs. So we'll have Quantum Eraser on doing all of his proofs. So yeah, come and it's going to be 5, I believe. I might just title it exactly that. 5 Flat Earth proofs, or something a bit more catchy. But that's 8 p.m. UK time. Be here or be sphere.
Okay, so we have another person here who suggests that the optical slant is basically caused by diffraction. That's interesting. Love to hear more about that.
Ruhif.
He fell asleep.
I'm on mute most of the time. What's up?
You want to talk us through the car crash of your most recent video?
What about it?
Well, you claim one thing, but indirectly make it look very flat in doing so. So I give you that your most recent video claims something to which I am not, something to which you are not. I'm making a point that you didn't claim in your video. I'll give you that. However,
So you're admitting that you're making shit up, Anthony?
no, far from it. Making shit up is not the point. What it is, you say one thing, but you present something that's the opposite, the antithesis. You
No,
claim,
I said I was presenting a 50-meter elevation, and I showed a 50-meter elevation.
yeah, but you flattened out the curve, Ruhif.
What does that mean?
It means that you've made a curvy Earth look flat, pretty flat. The problem is at 50 meters
I've
of
made it-
elevation. But just for the benefit of everybody in chat, Ruhif's done a video over a 30-mile observation, but on a 3D model. But what he's done is he's put the observer height from the guy that's the lens that's doing the model at 50 meters, which is about 160 feet. Now they're always telling us, these ballers, to get down low because it's super critical, the observer height. So I was quite shocked when I saw Ruhif's video where he's putting an observer at 50 meters, because what that effectively does is, even though he's claimed 50 meters and he's not been funny about what he's claimed, what he's actually showing is a very flat looking sphere, and he shouldn't be. He should be showing the curvature. Now you can't show curvature 50 feet very well, 50 meters very well. And I think it's misrepresentative, Ruhif, because it's not down low. Why didn't you do it down low?
I did 50 meters and then 2 meters. Is that okay?
Your main focus was on the 50-meter part, and that's the bit that showed
No.
right at the beginning.
No, it wasn't.
Yeah, it was.
The main focus is on the 2-meter part.
No, it's not. Let's have a look. Are we finished? Where are we at?
Hang on, I'll explain what I did first. The 50 meter, I set up 5 different columns, 10Ks, 20Ks, 30Ks, 40Ks, and 50Ks away from the observer, and showed what they look like from 50 meters so that you could see all 5 of them. Then I went down to 2 meters to show that the 5th one disappeared around the curve and matched the curve mass. That was the whole goal of the video, was to show that the curve calculator mass matches the perspective view of the ray tracer. That's the entire point.
So what? What does that prove? We're not comparing models with models. So what you're saying is you're comparing a pseudoscience model to your pseudoscience model to see if the pseudoscience model matches your model. Wowee, who cares?
That's what he's
not
done.
Understand what I just said?
Yeah,
but what
I
you've done
understand.
is
You've compared the metabunk model to a model you've created.
Yes, to a perspective view.
Sorry,
showing
I
that
don't give a crap what the view of your model is. Don't tell me it's a computer simulation. It's a computer simulation. It's not accounting for perspective. It's presenting it on a 2D screen and trying to do it with code, right? It's not reality. You're not comparing a photograph to the metabunk calculation. We show that and it doesn't work. You say, well, if I compare another computer model to it, it does work. Wowee! Who cares?
Yeah, I think the issue that you're not getting, Ruif, is that by comparing it to a 50-meter elevation and you're using the 50-meter elevation at the start of your video, what you're actually doing is presenting it as a flat world looking. You're not presenting it as the curvy world that we're supposed to live on. What you should have done is just do it at the 10 feet or 10 meters and left the 51 off it altogether, because it serves no purpose in the video. Because nobody needs to know what it looks like at 50 meters. We need to know what it looks like at low elevations where we're all told to get. So it misleads people into thinking that it's not that curvy at 50 meters, which is the beginning part of your video. It's misleading people into thinking it's not that curvy.
Nathan, it wasn't the wind turbines.
If I showed you one render from 2 meters, you would only see 4 columns.
Yeah,
correct?
That's kind of my point. That's what we should be seeing.
So, how do you know that there are 5 columns?
It was wind turbines.
Well, I've got to show you a picture from a higher elevation to show you that there are 5.
Right, but that's emphasizing how much curve there is, right?
The whole point of the video is demonstrating that the curve calculator results match what you see in a perspective view that does not use that curve calculator.
No, they don't. You're showing what it matches in a model, not a perspective view of anything. A perspective view would be something I took with a camera. You're just comparing a model with a model. If I say the Earth is a duck, and then I make a model of it, and you say the Earth's not a duck, and I go, here you go, I've made another model of the Earth as a duck, and it matches my model of a duck. What an absolute crock of crap.
Right.
So you're validating the model with a model, are you, Ruhif? And then claiming that because it's a perspective view in your model, that makes it work in reality? Is that what you're claiming here?
A ray tracer gives you a perspective view.
So what? It's just another model, isn't it? Do you live inside that model, Ruhif? Can you put your feet in that model? Is that where you live?
Put my foot inside your mum last night.
All right, ad hom insults. Is that the best you've got while I point out your absolutely crap argument, Ruhif? Do you think you're clever? You're laughing, but you're not clever. You're a dumbwit. That's what you are, stupid. If you think you can compare a model to a model and then tell me that's reality, unless you live in that bloody model, it isn't reality, you dumbass.
Right, Nathan.
Yeah, right. It is not reality, Ruhif. It's a model. Get your head out your ass and understand what I'm saying. Your model validates nothing. The original model validates nothing. They're just pseudoscience models. Get your head out of your model, mate. That's not where you live.
Nathan, was this the image you're talking about? I think it wasn't the turbines. I think it was the
No, I've got this one too. No, definitely not.
No,
so you've got it covering 4 out of 5 wind turbines. The last turbine, I remember saying to you, see, on the last turbine, you can't see any refraction because it's just refracted what looks identical, a pole, directly down on itself. So in one of the turbines, you've got just the pole, and it looks like it's going right down to the fake, false, artificial, recreated horizon that's below the real refraction band convergence point. But the rest of the boat shows on the word sea truck, like it does there. So you can see visually, obviously, with lettering, what is actually happening at the horizon, how it's distorting it. And the boat is approximately 50% between us and the wind turbines. But with, like I say, massive shout out to John for the super chat. But yeah, it's basically about 50%. Here we go. This is it. Excellent. Right. What we've got on screen now is something in the foreground, the boat, demonstrating precisely what is happening at the horizon and where the horizon is, and the effect it produces. Now, on the last turbine, you can hardly see it because it is essentially mirroring 30% of the turbine at the top down upon itself. So it is just a mirage below that actual fold line. I'll run my mouse for the audience's benefit, but this fold line is giving you the same above as below, and that is the true point of convergence. Now, anything behind this layer, which is obvious and observable in the imagery, totally impossible for any of these globe heads to actually replicate their 7.6R ray trace models coming around a curved Earth and then having a fold line mirage below itself. No one's going to ever be modelling that on a sphere. I absolutely guarantee that. But this is the actual effect.
I'm working on it, Nathan.
Sorry, did you say you've got one or you're working on it?
I'm working on getting refraction working in Povray.
Good for you. Have you done it?
Thanks.
Good for you. Have you
I've
done
got
it?
like really basic stuff working.
So have you got it working? Can you make looming and inverted mirage on a ball?
Looming, yes. Inverted mirage, no.
Sorry, Woolworm, what is your point? I just said maybe you're dumb as well as deaf, right? You will never replicate an inverted mirage that runs horizontally around a curve that is going away from you in all directions when the item looms up from behind a wall of water we never see. That will never happen. You will not model this.
Well, maybe you will, but it will be complicated. Fractal looming is very hard to work out.
Well, maybe he will. When he does, we'll have a look. We'll see if it matches anything. But so far, all you've done... Did you have refraction in your model when you were comparing it to the other model, as pointless as that was?
Did you watch the video? You'd know the answer to that, wouldn't you?
I don't watch your garbage. I've given up on you, Ruh, if you're a lost cause.
Fair enough.
So did it have refraction modelled?
No, I made it explicitly that it didn't.
Why not? Do you see this effect on screen, Ruhif?
Yeah.
Why would you ignore it?
What?
Is it like perspective? Do you just ignore that as well? So you ignore actual refraction in favour of bringing stuff back from a curve we don't see. What about the refraction that we actually see? You're telling me you're not modelling the actual observation. You said the other day that because the turbines were the incorrect height, that model was rendered invalid. So, Ruhif, from now on, unless you have these actual effects we see on screen, every model you present will be deemed invalid by me. Okay, idiot? You better get on with it.
Okay.
You better get on modelling what we actually see, Ruhif. Chop, chop, son.
Thanks, champ.
Yeah. If you don't come back with this, what we see, the obvious and observable refraction, in its entirety, how it works in the image, I will deem your model invalid. Your model that you most recently produced did not have this. Your model, Ruhif, is an absolute waste of time joke and invalid. It doesn't model what we see. A bit like when you invalidate someone else's model for it having a minor inaccuracy. That's precisely what I will be doing with you from now on. So why have you presented an invalid model based on your own standards of validity, Ruhif? Why are you so disingenuous? And a hypocrite.
Why are you such a cunt, Nathan?
No need to swear, Ruhif. Yeah, I haven't asked you for R yet. Normally you get this triggered when I ask you for R. So why have you modelled it like you have when it's ignoring very real artifacts in pictures? Why would you do that? Your model's invalid.
If you would watch my video, you would know.
Shut up! Answer my question. Your model is invalid. Your model is invalid. Why would you present it? Why would you present an inaccurate model, Ruhif?
You asked me a question and then...
Why would you model something inaccurately without the actual artifacts that we see in the real world? Why would you do that?
To demonstrate that the curve calculator maths is correct.
But we have refraction in images, real world, not the other model you're comparing to. In actual real world, Ruhif, on screen right now, there's some effects of it. Are you telling me you've just ignored that part of the very real world that we live in? Are you just going to ignore that? Your model's invalid because of your ignorance. Do you understand?
Righto, champ.
Not champ. You are ignorant of reality, Ruhif. Therefore, your model is invalid. So if anybody thinks Ruhif's model's good or supports their argument, it is invalid. And the reason is because of Ruhif's ignorance.
It's basically incomplete.
Yeah,
it doesn't match reality.
Correct.
Thank you, Owen. That's
yes,
valid.
that's right. Incomplete, incorrect, inaccurate due to Ruhif's ignorance.
Actually, it would have limited. Hang on, it would have limited validity.
Yeah, that's because it's a pseudoscience model. We already knew that. It doesn't have any validity. It's just a pseudoscience model.
Nathan.
No validity. Pseudoscience model.
Can I just say, to be fair to Ruhif, but it leads me on to another point. He has said that he hasn't got refraction sorted out yet. But we also know that Philip Weinberg and what's his name? Rumpus claimed that they were working on refraction some months ago. And I don't know, Rumpus claimed he was ready to do some kind of hangout based on this nonsense. And Philip Weinberg's in chat now. And I'm challenging you, Philip. You said that you would be able to do this ray tracing thing to explain the refraction on a ball. Well, let me just put it to you now. Iru Landucci's modelled it for everybody to see on a flat plane. And when you're ready, we'll present both models together. And let's see which one is most accurate with the reflection, with the rules associated with light and how light travels within our atmosphere. And guess what? Yours isn't going to do anything like what the light tells us it does in our own atmosphere. So let's see your modeling the refraction for the floaty land based on a sphere.
Yes, I'd just like to point that out and reiterate Anthony's point that Philip in the chat failed when he also produced a fallacious, begging the question, proof of nothing model that assumed R and did not include a very important aspect of the world we see, which would be this refraction. It didn't include that. He said the word refraction and just bent stuff back around the curve in perfect proportion without any of these effects that we actually see in the very narrow band at the horizon, at distance. He didn't actually achieve any of that because, again, like Ruhif, he is ignorant of reality.
Well, can I just tell you what I did with these images and how I got these? I was doing an experiment to find out if I lowered my elevation by 28 inches each time, what the difference would be whilst I followed this boat. So I think
your observed phenomenon?
Not an experiment. Yeah, well done, Ruhif. Thank you. I echo that.
Objective being not to go over a curve. That was the observed phenomena.
So I was seeing
this is not an experiment. Let's just get this nipped in the bud. Right, Ranty, your terminology was just wrong. You did a test. You made an observation. You maybe did some mathematics. You didn't do an experiment. Just to get that clear.
Okay. Well, I was doing some observations, and I was going to lower my observational height to see what effects this this layer of air would have on the boat. So essentially, these images were captured within a couple of minutes of each other. So I lowered myself from approximately 12 feet from this image, and then I went down 28 inches each one. And eventually I got down to this part here, which was about 1.5 foot. And then the last one, which was this one, was down to about 1 foot. Couldn't get any lower because the waves were too high. So dropping myself, so within 2 minutes, just lowering my elevation. This is the effect of the refraction at the horizon.
Yeah,
this is what we end up with.
A narrowing of the viewing angle.
Yes.
Something completely ignored in the begging the question proof of nothing fallacious calculations for a curved Earth. Viewing angles and perspective are just ignored completely.
And then, obviously, if you imagine him rising yourself up out of it again, what you see this Stena line is the first one that I get up. You've got a very nice reflection of the Stena line underneath it. And then the lower you go, that Stena line starts to merge into one another, and then it almost becomes readable in this one. That must be when I'm actually level with the refraction layer. And then when I go underneath it, everything starts to really, really compress to this point here. And there you go. So if anyone wants to use these images and try and figure something out with that, they're more than welcome.
The ones you thought you hadn't got 5 minutes ago.
Yeah. Well, I didn't
Thank
know
you
which
very
one you were
much. I'm
talking
glad you
about.
found them. I'm over the moon. I'm being cheeky and sarcastic, but yeah, I'm really delighted that you found those. Those are awesome. Can I just put them on big screen? If you can just flick through them again, I'll just make the hangout as big as
Yeah,
it'll
sure.
go. If you zoom in one notch on each of them, just so it fills the screen. Just so it can
Okay,
have a nice-
so this image was from approximately 12 feet in height. The next one, again, I'm lowering myself by about 28 inches because the steps are 7 inches high. I went down 4 steps each time. So I was effectively knocking 28 inches off my elevation. Next one. I mean, this is all good for collecting the evidence, you know, and sort of like trying to figure out what we're doing and what we're seeing, and what effects this has. There we go to this one.
Did you see what I mean with this? With the pole, you can see that the pole just looks like it's going all the way to the quote-unquote horizon with absolutely no interference. The poles just look right like they're normal, right?
Yeah.
Well, they're not. That's a mirage effect that's being affected at differing distances because of their angular size reduction. And it's essentially evening out this indifference between them at this point of convergence. But they are very much in this band. So the curved line you see is meaningless. It's just the angular size reduction at distance in this band of refraction causing the things that are in that level, depending on where they are going into the distance, because they're going to be smaller. So that little black band that goes around the bottom of these turbines in the other images gets stretched down and curved down towards the horizon because they're going further away from you and they're getting smaller, therefore bringing that band of that black stuff, wherever it may be, closer to the horizon due to angular size reduction. Closer to the horizon being closer to this band, therefore more affected by the mirage, more stretched, and that's precisely what you see. You see an increase in that miraging effect because there's various different points along the bottoms of those turbines that you can see the effects of it happening. There's a yellow band, there's a black band, there's a number, there's all sorts of different things that you can get reference to. But then when you see the boat going through it, you go, that's what's happening. This is the band that they're sat in. You don't get to see that clearly and obviously when they're just, you know, claim to be the full turbine height. Well, it's like we're not seeing the full turbine height. You know, we're seeing it down to this band. And then everything in that band is a reflection of itself below and above. And it's not really there. You know, in terms of the way they say, stuff that isn't really there is actually perfectly represented above that band. They say refraction's bringing it back from beyond the curves. Horseshit nonsense for just seeing stuff. But in reality, you do have a band of very, very narrow angle that you view things at in the distance that has this effect. And it's consistent. Unless Ranti goes a bit lower to the point where the waves intersect the midpoint instead, then they will obscure this line. But essentially, it's a pretty calm day, and he can see right up to the point that stuff is converging based on his angle of attack.
So we agree that the light curves, right?
No.
How do you get mirages without curving light?
Well, those are mirages, something that you can't model, right, Ruhif? So who cares? It doesn't support your argument, does it?
It's not bending, it's reflecting.
Sorry, this is just
Not
I just
bending
repeat that, Arwin.
light.
I just repeat what I just said. This doesn't support your argument. You cannot model it. It is not the refraction that you deal with. Your refraction brings things perfectly back from beyond a curve we don't see.
Anthony, you there?
Sorry, my name's Nathan. Right? You can't model this effect, so this does not support your argument, Ruhif. Are you going to address my statement, or are you going to ignore it and talk to Anthony?
I'm going to get Anthony to address your statement.
Don't get Anthony to. I'm addressing you.
Anthony, that
no. One more time and you just get kicked out. Your model cannot account for this refraction. You can't model it. And it is absolutely not part of 7.6R. So it does not support your argument at all. Tumbleweed.
Maybe it's time to go to bed.
It's almost midnight. But I want to see if Anthony's got that paper he had a while ago, that section 9 about mirages, inferior mirages.
Of course I do.
The vanishing zone.
Do you mean the paper that M. Scott Beach got removed off the MIT website when challenged to do so?
That's not what happened.
That is exactly what happened.
Oh, I even looked into that. It was that YT Cho guy or whatever, YTC, whatever his initials were. He is no longer at MIT. He was at a different university.
Yeah.
So they just
and one of
removed
them
his account.
One of them was from 2006 and the other one was from 2009. Why would they suddenly go off the day after I challenged him to get them removed because they shit all over his argument?
They're still available on the internet.
Yeah, but they're not on the MIT website anymore. Can you show where they are available on
Because
the internet?
the dude is not at MIT anymore.
Right, but I don't think...
Just as when I left uni, they deleted my account.
No, but I rang my university and from 2002, 3, I did it live with Nathan and they still got my account there. So I don't believe
they
that
have
for
your
a minute.
records.
I don't believe
They
that
have
for a
your
minute.
records.
And,
They do not have your account.
and even if it
sorry,
was
just
true,
to bring this back on track, why are we discussing this? None of the effects discussed in that paper, MIT or otherwise, support an argument of 76R. It's not accounted for, and you can't model it. So why are we having this conversation? This supports our argument.
No, we're talking about inferior mirages.
Really? And you model those frequently, do you? At the bottom of stuff that you say has been bent back, 76R refraction, terrestrial refraction, not this. Why you? Who's done? Is that Alan?
Yeah,
Let me guess. That was Alan, right? Yeah, terrestrial refraction, asshole.
Asshole. I love the way you say that, Nathan.
Yeah,
Asshole.
terrestrial refraction is what you're using, isn't it, Ruhif?
Terrestrial
refraction. What's the difference between refraction and terrestrial refraction?
Terrestrial refraction bends light 7/6 around a presumed radius that you have no evidence for. That is the type of refraction you are talking about when you reference refraction. Now you are talking about mirages, something you do not account for in the begging the question proof of nothing curve calculator, and something that you cannot model. It does not support your argument, it supports ours. Unaccounted for, unjustified, ignored by you. Until it's an argument that we start using, then you start, like most of the Globers, like Charles at the beginning of this show, asserting it like it's part of your argument. It isn't.
Did Ruud fall asleep now?
No, I'm sorry.
If ever you have websites that are deleted and stuff, there's a website that has a thing called the Wayback Machine, and it'll give you whatever it copied from the site. It's a database that tries to back up everything that's ever put under a DNS on the internet. It does a good job. It can handle, stored data and stuff like pictures and databases, but all static information, static images, all kinds of stuff is backed up as much as they possibly can. Anything they can parse. So if someone pulls down a site, check the Wayback Machine. You'll have most of the stuff.
Shout out to Joe for the super chat. Thanks a million.
Archive.org. That's part of the Wayback Machine.
Pretty handy. So Anthony, I want to see this paper that you have from the MIT guy, and how the light bends.
Which paper you're referring
to? The MIT guy. I'm on my phone, so I can't
three.
actually look
Are you on about the schoolboys one or the
yeah, I think it is. Not Diego Gutierrez, not that guy. It's the one.
It's the schoolboys one then.
I think so. Yeah, Section 9, Inferior Mirage, from memory.
Bear with me. Section.
There's a nice little diagram. Yeah, diagram of the vanishing zone.
I'll make your point about it. What's the point of this, Ruhif?
To show that light bends curves.
And does it show in that it bends at 7/6R, the same as terrestrial refraction, the same that's applied to the globe model, or not?
I don't think they did that in that paper. No.
So it's not supporting your version of terrestrial refraction then?
I believe the question was, does light bend in a curve?
Light does not bend. Light can be refracted into a different direction. Light travels in a straight line. Light does not bend.
Almost there. Oh, there we go. Look at that one. Thanks, Anthony.
Last time
that'll do me for tonight.
Last time I cited this, I was challenged on the basis that there was no axes labeled, and it was dismissed on that basis. But now you want to use it, even though it's already been by your lot dismissed because
That's
there were
right.
no axes labeled.
What are the axes, Ruhif?
I haven't dismissed it.
What's the
But
axes
your lot
then?
did.
Just tell us what the axes are.
I haven't dismissed it.
What are the axes, Ruhif?
I have no idea. I can't see it.
So who cares then, right? We can just dismiss it.
They're clearly light rays, though, right?
Sorry, light rays travel in a straight line. They can be refracted into a different direction, but they travel in a straight line. Does this have an axis?
Looks
You
pretty-
can tell us
pretty
what we are
curvy to me,
looking
Nathan.
at. If you don't know what the axis is, I think we'll just move on, Ruhif.
Okay.
Well, hang on.
Light doesn't bend. It only bends if it is physically or not physically, if it is optically reflecting from something like a optic fiber cable. So it has an actual edge to then reflect against.
Surface.
Yeah, that in that sense, light can reflect, but in regular, non-bordered atmospheric conditions, it cannot do that. It will travel in a straight line.
I think it was actually Mick West himself.
Oh, really?
Praise
Mick
Helios.
West? No, that's lovely. Mick West and his
praise Helios.
calculator that doesn't work.
I've just demonstrated that it does.
No, you haven't. Where did you demonstrate that it worked? When you compared it to your pseudoscience model?
To a perspective view ray tracer, yes.
Sorry, a pseudoscience model in a computer that you don't live on. Was that comparing it to reality to see if it matched reality? Or was it just comparing it to your pseudoscience model? So if I've got a chicken and I say this chicken is Earth, here we go, check out my computer simulation of why this chicken is actually Earth. Not like Earth, is Earth. And you go, no, that's ludicrous. I've got my feet on Earth. And I go, no. Look, I've made another model. And it proves my first model. What are you, dumb?
Dumb. I love the way you say that as well, actually.
Hey,
Yeah, you're a Dumbo.
You might
if you
be
think
able to
your
make
pseudoscience
light
model
bend
proves the
in a
model
ray
that we have
tracer.
debunked on countless occasions, you're a Dumbo.
Hang on. One person at a time.
You're Dumbo. Did you hear that?
All right. I heard that one, yeah.
Just because you are able to make light or basically visuals in a ray tracer follow a curved path, because you can manipulate that kind of thing in a computer simulation, doesn't mean that that actually is physically or optically possible in the real world.
Physically, optically.
That's what I'm saying, is that Mick West is, I'm pretty sure it's Mick West. Like, he basically gets a laser pointer.
Did you hear what I just said?
Yeah.
Just because you can manipulate a computer program to make light behave a certain way and follow a curved path doesn't mean that light is then optically, according to physics, able to do that in the real world.
Yeah, can I finish my sentence now?
It's a manipulation. Doesn't mean it is actually possible in reality.
Right. So Mick West has done a in the real world demonstration of light bending.
Really?
Go on. What did he do?
Yes.
Sure.
I'm fairly sure it's on his
What
YouTube
did he
channel.
do? Let's hear it. What did he do?
He pointed a laser pointer at the wall, I don't know, 10 meters away or something, and filmed with his camera zoomed in on the laser pointer where it hit the wall. Then he brought in some heat towards the laser pointer and showed that the heat caused the light to bend
So did he change
laterally.
the temperature by about 35 degrees or something exponentially stupidly high that we never see in the atmosphere, right?
What did he heat up?
This is over 10 meters, right?
What did he heat up? Just tell us what he was using as the heat source.
I think it was I don't know, candle or something. I don't know.
Right, and how hot is the flame of a candle? 2,000 degrees or something?
No.
100
All
degrees?
he's demonstrating that heat causes the density to change.
Yeah, but there's a
causes
scale
refraction.
thing. You understand how scale works? Like we have microscopic millibar changes in pressure or temperature.
According
or
to
density.
Wikipedia, a candle flame usually burns at 1,000 degrees C. That's interesting.
Sure.
Seems a bit harsh, don't you think?
Seems quite intense, don't you think?
Does heat cause the density to change? Yes
Does
or no?
1,000 degree heat cause a density change that can cause straight lines to refract? Yeah,
and this
1,000 degrees might do that.
And just because the light changes direction doesn't mean that it is bending in a curved form. Means it is changing direction, just like refracting through glass or through a water surface.
In addition,
Or if you have a gradient.
in
If
addition,
you have a gradient, yeah, it's going in a straight line after
Really?
that certain
Yeah.
point where the heat is.
in addition, Ruhif, it's
Gradient.
the same as arguing that the Dang-Joss experiment, where he used liquid butane that was somewhat like minus 30 degrees, in somehow is comparable in our atmosphere because we don't see temperature fluctuations anything like that. So if you're going to argue Dang-Joss
course.
representing
That's
our
why they're
atmosphere,
doing it on such a small scale. They need those huge gradients
who
to
cares?
do it on a small
Changes
scale.
don't happen like that real world. So
It's
what
not
you're
the
doing-
real world, Ruhiv. It's not the real world.
Yeah, and refraction doesn't really happen in the real world over 10 meters,
Right.
does it?
Correct.
Just before we,
Two
just
meters.
before we round out for a short break,
Exactly.
sorry guys, can I just ask Ruhaf what you said? If you've got a gradient, what were you talking about there exactly?
I can't hear anyone, by the way.
Sorry, you said there was unless you've got a gradient. Did you want to expand on the gradient that you were talking about?
From like 2 minutes ago?
Yeah.
I forget the conversation. What was saying?
Yeah, you
I
said
suppose
it.
what he's asking you is what's a gradient compared to a subtle 1,000 degree candle flame?
What
Well,
gradient are you
the
talking
refraction
about?
that we see over long distances is obviously a very low temperature gradient or density gradient.
Yeah.
So we need to manipulate the
Why
high
is it? Why
temperatures
is it a
or-
gradient though? Why is it a gradient?
Why is there a gradient in the atmosphere?
Yeah.
No. What?
Yes. Hold on, Anthony.
Yes, no. What?
Anthony, hold on. You're saying if it goes through a gradient. Well, why would you assert that there is a gradient between me and a target?
Because
point.
there is. There's pressure and temperature differences.
What are the
Really?
differences?
That much?
Oh, Arwin. What are the,
I was waiting for you to say that.
what differences? What differences? What are you talking about?
I'm talking about temperature and pressure gradients in the atmosphere.
That,
Do you
how does
reject that they are there?
No, I'm trying to get to the point where we get to 76R, terrestrial refraction, the thing that's applied to the sphere model.
Yeah, I made an entire video on this.
So it's
I'm not,
based
I can't
on.
run
So hold
through
on.
it here.
So it is based on terrestrial refraction 76R. So the gradient is the gradient through this R value, correct?
The
Take your
gradient
time.
is the gradient through this R value. Yes.
It is. So the gradient, the gradient you're saying it goes through is based on a presuppositional sphere Earth with a presupposition of terrestrial refraction bending light around a sphere Earth. So it's all based on R, basically, that gradient.
Haven't we been through this?
Do you understand? When I put a question mark on it, I don't want you to ask me whether or not I've gone through it before. I understand that you're slow. Things need repeating. So,
Well,
your
apparently they do need
gradient, let
repeating,
me just
'cause we've been
repeat it,
through
Roo.
this.
I want to round out for a little break. You're getting tedious. I'd already given up on you, but your slowness is entertaining to others. Yeah? You've got a gradient, and that gradient is based on a presuppositional value of R. Isn't it, Ruhif? Yes, is the answer.
The
yes.
gradient.
Just
the
say
gradient, no.
yes. Just say
The gradient.
yes.
The gradient, no.
So
It's
it's
not
not
to
the
do with
gradient
the
isn't
gradient.
going around a curve.
The gradient is going around a curve. so
Right.
it's not based on.
So that curve
There
has a
is a
value
gradient.
of R that you have presupposed. Correct?
Do you know the point of the
Don't
video,
ask
mate?
me
We've
anything.
been through this.
Don't ask me anything. The gradient is based on R. Just say yes.
No. There is a
Sorry,
gradient.
so
irrespective
we've just
of
established that that it goes around a curve, doesn't it, Ruhif?
The gradient
Why are
does
you
go
now
around a
being a
curve.
slippery little sod?
Because you can't phrase a fucking question clearly.
Oh,
Nathan.
you're going to start... It always gets to the sweary, Ruhif, when we ask for R. So your gradient's based on your begging the question fallacy, is it, Ruhif? That gradient, you're going to say it's bending through?
The gradient is not
It's
based,
based
on R.
on terrestrial refraction. 7, 6, R. You just made a video about it,
gradient-
dickhead. Didn't you?
The gradient is not based on R.
So
Listen to my words.
7.6R is not the terrestrial refraction you're applying.
Yes, it is.
Right! So you've got R! For the love of God, you absolute buffoon! Yeah? All you're doing is humiliating yourself. You've got a presupposition that the atmosphere bends around a curve. 7.6R.
Yeah, and I desperately want to
win!
Come on, Nathan. Come
shut
on,
up.
Nathan. I can disprove his gradient.
Shut up, Arwin. Shut
no,
up.
You can't disprove the gradient.
Shut up,
yeah,
Arwin.
You can.
Back.
Yeah,
Ruhif.
it's not how refraction
Ruhif,
works.
your gradient is based...
No, not to the rescue. No. I just want to disprove his
thanks,
point directly.
Arwin. I've got him on the ropes and you're answering for him. Wonderful. Ruhif, it's based on R.
What is based on R?
Terrestrial refraction. 7.6R. Why are you laughing?
Useless pursuits.
Do you think this is funny? You're absolutely pathetic, Ruhif. Do you know that? You are quite possibly the most pathetic, indoctrinated glober I've ever had a conversation with.
I've had my humiliation tonight, when I can go to sleep now.
Yeah, you deserve it. You're a pathetic little weasel. Yeah? You can't even admit when you've got a presupposition. You try and dance around it because you're a little weasel.
I've explained several times what the video is about and you just don't get
7.6R is what your video is about. And I asked you before you made the video, are you going to prove R? And you said, no, it's not part of 7.6R because you're an absolute moron. You literally say, I'm going to prove 7.6R, and in the next breath say R's not part of it because you're a buffoon. You're an idiot, and that's what you've got to offer. A bit of giggling when we have your toes to the fire, Ruhif. Yeah? Like we do daily with other religious zealots that are just as bad as you are. And with that, I'm going to say first and foremost, a huge, massive, enormous thank you to all of the live audience for tuning in and hopefully sharing this debate. And of course, a massive thank you to all of the live panel for making this debate possible. If you hated the show, you know exactly what to do. But if you like the show, maybe consider sharing it with a friend or subscribing if you have not done so already. I've been Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!